In 1935, Australia introduced these toads to eat crop-destroying beetles. But the beetles survived just fine, and the toads exploded in numbers and became one of the country's biggest ecological disasters. For years, Australia tried to wipe out the invasive cane toad, and every time they hit the same wall. A predator grabs the toad, and a minute later, the predator is dead from the toxins. It seemed like this creature simply had no natural enemy. But then, on the shore of an ordinary pond, scientists started noticing something strange. Tiny toads would crawl out of the water, and ants were waiting for them. The ants swarmed in, grabbed the toads, dragged them away, and literally cut them to pieces. And here's the key. The toxin that kills larger animals barely affects the ants. Australia's native frogs learned long ago to stay away from these ants, but the invasive toads never did. Next, the Australians started herding all the ants from the forest into one spot right where the toads were. And what happened afterward shocked even them. The first and main question is, why does toad venom drop snakes, lizards, marsupials, even crocodiles, but ants don't care at all? You'd think venom should work on everyone. A universal defense. Smear yourself with toxin like the smartest creature alive and boom, you win. But real life doesn't work like that. The cane toad's toxin really does work great against vertebrates. Their physiology is similar. The same buttons the venom can press, heart, nerves, breathing. One chemical trick can wreck all of it. Insects just aren't part of that system. They're different across the board. What's a lethal hit for a lizard or a snake might be nothing more than a weird flavor to an ant. Ew, why is this tasty? So yeah, the toad invested in protection from big predators when it really should have looked where it was stepping at least once. And that's when I realized I should quickly explain why cane toads became such a disaster in the first place. In general, when a species suddenly shows up everywhere all at once, it almost always means people brought it there. That's exactly what happened in Australia. In 1935, cane toads were imported as a kind of biological weapon against beetles on sugar plantations. The plan sounded perfect. The toads eat the insects, the crop is saved, everyone's happy. Instead, the beetles were just fine, and the toads went completely out of control. With no natural predators, a powerful toxic defense, and an insane breeding rate, they started spreading across the continent, eating anything they could swallow along the way, and poisoning anything that tried to swallow them. The toad that was brought in as a solution ended up becoming the problem. You can see it clearly on the distribution map. In the 1930s, the toads advanced slowly, only about 6 to 9 miles a year. But after that, the pace began to pick up. The larger the population grew, the faster it spilled across the landscape. By 2015, in some areas, their advance reached 31 to 37 miles a year. Obviously, stopping this toxic steamroller's basically impossible, unless you know where to hit it. The logic is simple. It's easier to deal with the ones that are forced to gather in one place than with those already scattered in every direction. Cane toads have such a moment, the stage right after metamorphosis. In other words, yesterday's tadpoles that climb out of the water all at once. Around a single pond or puddle, a living, shifting mass suddenly appears, hundreds of tiny toads. That's exactly when the ecosystem gets a rare chance to strike back. So how can ants take down a vertebrate? Honestly, if the victim is tiny, raw strength isn't the point anymore. What matters more is numbers and speed. A little metamorphed toad has just crawled out of the water, slow, soft-bodied, and disoriented. And that's exactly when an entire swarm hits it. Excuse me, could you tell me how to get to... Meat ants pile onto the prey, biting, latching on, holding it in place. The toadlet jerks and thrashes, trying to break free, and very quickly, it stops moving. But then why don't the ants finish off all the local frogs right there on the doorstep? Because the locals have been living with them for ages. They know what to do. Freeze at the right moment, twitch at the right moment, and bolt the right way. But the cane toad doesn't. Honestly, it looks like it can't be bothered to move unless she absolutely has to. Its newly metamorphosed toadlets react worse as well, and sometimes they don't register the danger at all. Scientists even tested this. They took a cane toad in 7 native species and compared everything. Maximum jump distance, sprint speed, and endurance. In every test, the cane toad came out last, slower, shorter jumps, and it tires out faster. And there's one more key detail. Cane toads are especially active exactly where and when predatory ants are active. Here it is, classic evolutionary trap. Want to know why? The toad evolved in South America, where there simply aren't big predatory ants like this, so it never developed the right reflexes or the right behavior. In Australia, the rules are different, but the toad's still playing by the old ones. So here's the next question. Why do ants even find the little toad in the first place? Honestly, it's not complicated. All it takes is a bit of commotion on the shoreline, and that's it. You've been spotted, and you're about to get eaten. Welcome to Australia. And this isn't some theory worked up in a lab. In the field, people have actually watched ants drag off and eat cane toad metamorphs. The timing is perfect, too. Ants are active during the day, and baby cane toads are as well. Most native frogs are smarter. They come to the water's edge at night. But young cane toads have a different problem. During the day, they can get eaten by their own kind. The risk of cannibalism from larger toads is so high that the metamorphs only crawl out of the water in daylight, straight into the ant's grasp.
Let's put a few dollops of cat food out beside the area where the toads are coming out of the water.
And then the scientists decided to take it a step further. Not just watch the ants, but give them a little motivation. Boost the effect. Thousands of individuals and all that. It's easy to picture something totally insane here. People hauling truckloads of insects, dumping them by the thousands, and suddenly it's some kind of biological apocalypse. But no, it was nothing like that. Instead, they started laying out bait in the spots where the toads pour out of the water en masse. For example, cat food. And it worked. No, wait. It worked! The moment a food source appears, the ants swarm it fast. Within just a few hours, a shoreline that was relatively empty turns into a hot spot of ant activity. And from there, nature does the rest. 98% of the toadlets come under attack by ants in the very first minutes. But ants don't choose to eat frogs, they grab whatever they can carry off. Isn't that dangerous? It is. Any kind of biological control usually risks not only hitting the target, but also affecting its neighbors. That's why the strike is aimed at the stage where the targeted species stands out the most compared to the others. For cane toads, that happens right after metamorphosis. By now you've noticed that their young behave differently from local frogs, so it's not hard to tell them apart. Ants don't care who they eat, but it's much easier when the meal can't fight back. Now let's figure out why ants become such a brutally effective weapon right by the water. It's not just the water itself. The shoreline isn't simply the edge of a pond. It's a narrow passage the young are forced to funnel through. Kind of like an amphibious landing. Only these metamorph paratroopers are pretty pathetic. Tiny, thin-skinned, and they dry out fast. They can't head straight inland right away, it's too risky, so they're stuck hugging the damp strip right along the waterline. And that's exactly where ants get their perfect conditions. In tropical Australia, people see this all the time. Around waterholes, meat ants consistently prey on toad metamorphs. If ants are so good at wiping out the juveniles, why haven't cane toads been wiped out by now? Sadly, the impact is real, but it's local. It all comes down to conditions, how dry or wet it is, what the shoreline is like, sand, clay, rocks, whether there are cracks and hiding spots, and exactly where the ant nests are. In some places, ants get a perfect hunting zone. In others, cane toads simply aren't on the menu at all. And the toads aren't completely defenseless. Newly metamorphosed toads can climb onto tussocks, floating debris, any little rise above the water, places the ants physically can't reach. So yes, ants do crush the youngsters, but it's not enough to stop the toad avalanche. You know what really turns the shoreline into a meat grinder? It's not just the ants, it's what kind of shoreline it is. For an adult toad, it's just the water's edge. For a metamorph, it's an obstacle course where any tiny bump can become a trap. What looks like slightly flattened dirt from above is, for this little guy, a massive lunar crater. One small step for a toad, one giant leap for toad kind. Oh, f***. Little pits, hoof prints, sunken patches, cracks, and dried out clay, every bit of that terrain raises the risk. The metamorph gets stuck, loses speed, and that's it. The ants don't even have to chase. Meanwhile, the baby toad can't really do anything, even though it tries. It jerks, squirms, signals, only making itself more noticeable to its killers. And yeah, in the end, it's almost like a dark joke. A cow walked by, and life genuinely got worse for the toads. Hooves create microterrain, microterrain slows down the young, and the ants are already here because the shoreline is their work zone. So even without more ants, mortality shoots up. Are the cows in on it? I honestly never thought about that. When you add it all up, everything is working against them. The coast turns into a tight passageway. The tiny terrain features are full of traps, and on top of that, ants that are always starving. Which raises an honest question. Is this a truly significant effect, or just the impression that, wow, a lot of them are dying? If we're talking about real impact on the population, it should show up in the numbers. And the numbers here are pretty striking. More than half of ant attacks on toad metamorphs end in instant death. And even running doesn't help, because among those that do manage to break free, the overwhelming majority, about 88%, die within the next 24 hours. Not to bigger predators, but from the aftermath of those same attacks, injuries, stress, and damage. So sure, you escaped, but what's the point? In the end, ants don't just hit individual animals, they hit whole generations, turning the move onto land into a stage with extreme mortality. Why are cave toad metamorphs so helpless anyway? The thing is, metamorphosis isn't an instant upgrade. It's long and complicated. The body is basically installing new firmware, breathing, skin, the muscles, moving, the whole physiology gets rewritten. Yeah, at a moment like that, you're definitely not thinking about ants. On top of that, metamorphs are tiny and lose water fast, so they're forced to stick close to the shoreline. You can't stray far from the damp zone, dry out, and you're done. From a predator's perspective, they're almost perfect prey, small, slow, and packed into a narrow strip of habitat. Wow, like the beavers of the amphibian world. But cane toads have one more problem, which I mentioned earlier. As a species, they evolved in places where there simply weren't big predatory ants. So on an evolutionary level, they basically have no idea what to do about ants. Instead of fleeing, many metamorphs rely on camouflage. And yes, that works against birds, but you can't fool ants. So if all this sounds so promising, why not just roll out ant armies all across Australia? Unfortunately, ecology is wildly finicky, and it doesn't fix itself with a snap of the fingers. You brought those toads here? Well, enjoy dealing with them. Ants aren't a controllable tool. They're actual predators. If you blindly boost their numbers, they'll start eating not just toads, but anything else that fits their diet, and any artificial population boom of any species is always a risk, even if the goal seems noble. You know how many times people have wrecked ecosystems with good intentions? If you've been watching us long enough, you definitely know. In short, ants aren't a win button, they're an opportunity. One possible piece of a bigger combined approach. Maybe you're wondering, why do cane toads damage nature so hard? It's simple. Their toxin is built right into their bodies, and predators don't see that betrayal coming. They think they're doing the usual thing, trying to grab a meal, but instead they get poisoned, cold and dirty. This is outrageous. I'm going to complain. All sorts of animals have suffered because of these toads, from snakes and monitor lizards to carnivorous marsupials and even crocodiles. Species that spent millions of years hunting harmless amphibians suddenly ran into a toxic trap. Good thing, at least, that their urge to eat something exotic doesn't end in a pandemic. Instead, the toad acts like a poisonous ecological trigger, knocking out entire links in the food chain. A strange paradox. The cane toad's toxin makes it almost untouchable for big predators, yet it doesn't save it from the tiniest ones. You've probably already guessed why. Toad toxin works great when it ends up in a predator's mouth, but ants play by different rules. They don't try to swallow prey whole, they just tear it into pieces. In that scenario, the classic toxic defense barely works at all. The toxin won't stop dozens of small attackers who aren't gulping their victim down, but calmly dismantling it bit by bit. So here's what I'm wondering. Aren't ants afraid to touch toxic skin? No, they probably don't experience fear the way we think of it. But if toad poison were a serious problem for ants, we'd see a different pattern. After the first bad encounters, the attacks would drop off sharply. In the wild, predators learn fast to avoid whatever can kill them. But that's not what happens. Ants keep attacking and eating young toads again and again, regularly, which means, in practice, the toxin is basically a non-issue for them. Just tastes nasty, like I said. And the toad is poisonous at every stage of its life. The toxins are present in tadpoles and in metamorphs too. The young are less toxic than the adults, sure, but the poison is still there. Ants just don't care. Like honey badgers. If ants are consistently munching on toads, then either the toxin isn't lethal to them, or it has a weak effect. Not strong enough to make them pass up a toad snack. Let's set the cooking metaphors aside for now and get back to Australia's war on cane toads. If things are going so well, why not just bet on other insects or predators instead? Because there are several fronts at once. There are eggs, there are tadpoles, and there are metamorphs, different life stages, in different environments with different weak spots. No single predator can realistically cover all of that. Ants do their part on land, targeting the metamorphs. But that's only one layer of control. There's evidence that some invertebrates readily eat the earlier aquatic stages too. At least 3 species, 1 beetle and 2 true bugs, don't seem to be affected by the toad's toxins and successfully feed on eggs and tadpoles. I wouldn't say these guys are exactly working together, but they're not competitors either. If anything, they complement each other. The result is layered control rather than a single silver bullet. One group eats eggs, another goes after tadpoles, another targets metamorphs. Some are bugs, some are ants. By the way, when people say ants, who are they actually talking about? It's not one species, it's a whole cast of different predators. The more participants you have, the stronger the potential effect, but the harder it is to predict exactly how it'll play out in any particular ecosystem. Studies mention a wide range of invertebrates. For instance, the nymphs of the dragonfly Pantala flavescens and clever fishing spiders Delametis facitus selectively ate cane toad tadpoles, sometimes even more often than the tadpoles of native frogs. In other words, the pressure starts in the water long before the toads ever reach land. But if we're talking specifically about land and about mass die-offs of newly metamorphosed toads, then the key player is someone else. Ants of the Iridamyrex genus, the famous meat ants. They're the ones most often identified in field observations as the main predators of toads after metamorphosis. Big, aggressive, numerous, and perfectly adapted for hunting around water holes. So, ants versus toads isn't an abstraction. This story has very real, very specific characters. Someone will have to hand out medals if the war is won. Lots of tiny medals. By the way, why do headlines love calling them soldiers while scientific texts call them meat ants? Because soldiers is a punchy image. It instantly conjures an organized army, discipline, tactics, something like a military operation. In reality, the mechanism is much simpler and much more biological. They're called meat ants not because of some edgy, aggressive label, but because of their strategy. They're abundant, active, and they hunt by sheer numbers. What matters here isn't individual strength and definitely not resistance to toad toxin. What matters is quantity. Well, it's not that bad. I thought it'd be worse. Not one attacker, but dozens at once. A swarm of tiny jaws that smothers the prey, bites, pins it down, and physically overwhelms the victim. So what, should we just import even meaner ants? Smell that? Smells like a real shitty idea. Treating one invasion by unleashing another is a classic way to end up with a bad ending, just with a new villain. A perfect example is fire ants. They're a major problem in their own right, including in Australia, where people already have more than enough trouble with them. They're prolific, tough, ravenous, and extremely aggressive. They don't just bite prey, they operate like a military unit. They sense a threat and attack, coordinating with pheromones, biting and injecting a potent venom made up of dozens of chemicals. That's not targeted pressure on a vulnerable stage of the toad's life cycle anymore. It's a brand new wildfire in the ecosystem. Fire ants can bring down animals far larger than themselves, including humans, and their arrival will definitely not make things better. In short, don't go hunting for an even scarier predator. Work with the ones that are already there. This is a much more cautious path with a far lower risk of accidentally making things even worse. Worse than this? Come on. The rabbits are driving me insane. When there's already a predator in the ecosystem that can suppress an invasive species, you don't need to reinvent one. You don't need a new introduction with new, unpredictable consequences. You just need to carefully strengthen what's already there. The point isn't to boost predator numbers without limits, it's to steer its hunting pressure to the spots where beating back the invader is simplest. With cane toads, that means focusing on the shoreline areas where the metamorphs emerge in huge numbers. In short, minimal intervention, maximum use of what nature already knows how to do. The real question is, can we make the strike surgical and avoid hitting anything we don't mean to? That's basically the whole strategy. The emergence of the toad metamorphs is tightly linked to a specific place and time, which gives us a narrow window to act. Everything lines up in one moment. The rainy season, the water's edge, and that morning window when the ants are already active, but the metamorphs haven't dispersed yet. In that brief period, the young are packed together, most concentrated and most vulnerable. So is this a victory or not? In ecology, beating a species almost never looks like 0 individuals left. Usually it means something else. The population stops exploding at a terrifying pace, the pressure on the ecosystem eases, and the numbers take a noticeable hit. Basically, that's exactly what the researchers are hoping for. Expecting anything more at this point is, well, a bit too late. But why are toads, those animals people love to call practically indestructible, starting to lose? Because their defenses were built for a different kind of war. Nobody told them they'd be up against thousands of furious insects, and it seems Australia really might have a shot at getting even. You owe me a like. See you later.